So here's a simple line diagram that I can use it as an example. So fuses keep blowing. So let's say this 2 amp fuse here blows. It's no good. You replace it with a new one, and as soon as you hit the push button to close this circuit, it blows again. So fuses blow when the circuit overloads, right? It overamps. The fuse blows to protect the circuit. There's only a couple possibilities here. Either your green light is drawing way excessive amps and is causing the fuse to blow, or you can have wire shorts. So if this wire here shorts to this wire, you're going to have a short, and that's going to cause your fuse to blow, because without the load in between, you're just going to be sending 120 directly to your neutral. That's going to cause a excessive amp draw. So you can isolate your load from the circuit to determine, is it my load that's causing my fuse to blow, or do I have a wire short somewhere? You can use a resistance test to determine that. So you can go ahead, look for the disconnect coming upstream, kill that disconnect to stop the 120 feeding to your circuit. And of course, always verify with your meter to verify that the 120 is no longer live and this circuit is de-energized. Go ahead and set your meters to ohms. Take one lead and place it to the line side of your fuse. Take the other lead and place it to a point where the neutral is located. Now with your meter lead in parallel to the circuit, you can go ahead and close the circuit by hitting your push button. Close that, and now you will have a closed path here. And what you don't want to see is a low resistance reading. You might see OL or a really high resistance reading, but you do not want to see a resistance reading of less than 1 ohms. So if you go and close the circuit and you see a resistance reading of something like that, 0.01 ohms, that indicates that you have a direct short from your line side to your neutral, and that will blow your fuse every single time you hit that push button. So if you have a short, it can either be shorted through your load, or you can have a wire short like I mentioned earlier. So we can isolate our load from the circuit. So this wire going into our green light, we can remove that wire and we can redo our same tests. And after you isolate the load from the circuit, you repeat the same test. You hit down the push button and you no longer see that low resistance reading. You know that the load was what was shorted, and that was the cause of why your fuse was blowing, because your load internally is shorting your 120 to your neutral. It doesn't become a load anymore. It just becomes a path for electricity to get from your hot side to your neutral, which causes that really high amp draw, and it blows the fuse. On the other hand, after you isolate the load, you repeat the test, and you still have a low resistance reading, then that tells you that you have a wire short somewhere. A wire on your line side is shorting to ground, or it is shorting to the neutral side. A lot of times, neutral is also bonded to the ground. So if this wire would rub, it would rub and touch something metallic like the cabinet or something that is grounded, it would also cause a short. It would be the same as sending 120 directly to ground and neutral. So that would also cause that really high amp draw to blow your fuse. In that case, just take a lead and place it to a point on the neutral ground side. Take your other lead and just start probing each point where the wire terminates. So you probe here. Do I have a resistance reading? No. Probe here. Do I have a low resistance reading? No. And then you probe here, and all of a sudden you get a beep, a continuity tone, or a really low resistance reading of less than 1 ohms, or any sort of low resistance reading. Then you know that somewhere on this circuit right here, this wire here, is shorted. So go ahead and inspect that wire. It might be rubbing through, touching something metallic, or rubbing together and touching a neutral wire. If it indeed is a wire short, by testing it this way in ohms or the resistance test, I've always located where my shorted wire is. So I hope this kind of gives you a better understanding as to why fuses keep blowing after you replace the fuse. Until next time, deuces.